Okay. Yeah, you should hear me. I hope. Hello, guys. Uh, my name is Marko Petrlic, as you can see on the screen, and my goal today is to show you how to deploy your own chain, basically. Start a private network or a public one, however you call it. It's not really that hard. It's a bit time consuming, you will see, but no special knowledge is necessary besides knowing how to use a terminal, how to use Git and everything. Uh, I tried it yesterday to see if I can actually do it, and I was able to do it without any issues. So yeah, I'm not hoping that we're going. I don't think that we're going to have any issues today with that. If we will have, we will debug them live, basically. uh, if you have any questions, feel free to write them down. If I will have the moment, I will read them. But I will do my best to be fully focused on the goal today, and that's the building and deploying custom chain. Uh, so yeah, the goal is to have a really simplified version of the chain deployed, probably just 3 nodes, or to be more precisely, VMs. We're going to have a public one, a boot node, and a validator node. We can actually do it without the validator node, so just the public one and a boot node. But to give the whole chain a bit more complexity, it's going to be 2 validators instead of 1. Because that's the usual case. When you run a completely new chain, you mostly have like 2 or 3 boot nodes and a couple of validators. Be this whole live stream will be done in 2 or 3 parts. Um, I will see if I will need to take some breaks, but my estimation is like 2 hours. It's going to be long 2 hours or maybe 1.5. We will see. It depends, on what kind of questions we get or what kind of questions I get, and if I'm going to have some issues or not. I will start immediately. I will be not. I will try my best to look, at the camera, but it's not gonna be that easy because I got you guys on my second monitor. So let me just share my screen. Share screen. Screen 1. Okay, let me see if I can make it bigger. Yeah, I hope I'm not going to be an issue, that my camera isn't going to be an issue, but let's immediately start. So I've written some steps on what exactly you need to do. Let's see, maybe I should make them a bit bigger. I think it's fine. Let me in the comments know if you need bigger text or bigger font. So first, what we're going to do is we're going to just deploy 3 VMs. We're going to call them public boot node and validator node. And once we are done with that, we are kind of done with the DevOps part for this segment. Then we're going to build the node binary node, and then we're going to generate all the stuff that we need. Once we have generated the stuff that we need, we'll copy paste the data to the chain reference, to the reference chain specification, build a new chain specification, which is going to be in the raw format, and then we'll configure our boot nodes in validator nodes and our public node in the end. The only difference between the boot node validator and the public node is that the public node is going to configure NGINX so that we can connect to it using WSS or secure WebSocket. So let's start by bigger. So let's start by actually doing the first step, and that's to create or to deploy 3 VMs. I'll do it on Scaleway, but you can do it on your with any provider that you want. So I'll just 1 second. I'll make this smaller. So I'll go to Scaleway. So like I said, I already have tried this yesterday and I didn't had any issues. so I'm not expecting to have them right now. So I'll go to my own project, and I will just first make the whole interface a bit bigger so it's visible. I'll just make 3 VMs. They're going to be dev test. They're one large, so it's going to have 4 cores, 8 gigabyte of RAM, and some storage. So this one we will call public instance. Okay. Then the second one is going to be, the boot node. Doesn't really matter where the VM is located, I'm just going to do some. I'm just going to show you how to deploy, and after that I will just remove the VMs. So public, now we need the boot node. Public boot node, and we need one more, which is going to be a validator node. So boot nodes and validator nodes are the same. Boot nodes usually are validator nodes, but they're called boot node because this is how you connect to the network. You first contact them, validate, and you'll see later. You will see how this will be reflected in the chain specification. Yeah, so let's wait a couple of seconds for this one to be created, and then we will go to the next step. Right now, we're not going to go into them or install anything or configure them in any way. This will be done a bit later. So yeah, let's see. Yeah, he should be okay. So what we're going to do is we're just going to go to the node GitHub page and node dash node and get the code. So make it bigger. Code, yeah. So here I create a folder called live test, so that I can group all the stuff that I create during the live stream. Here I just clone it, so it clone, yeah. And I will put depth 1 so that oh my god, so that we don't wait too long. Okay, that was quick. In here I will just do cargo clean. Yeah, first, yeah, I forgot I need to initialize the dependency that I have, and that's inside the Tanoa palette. So let me just see what command I need to run. Yeah, I need to do the Gibson module update command. Okay, I will close my other console, which is unnecessary, and I think that I can do git cargo clean. Yeah, and then I will do cargo show. It's not so. It's last up show. Just to make sure that all my toolchains have been installed and I have the right Rust version. And after that, I'll do cargo build, please. But this will take a while. Yeah. Boot nodes do. Usually they are validators too. So when you're creating your chain and you want to have let's say 5 or 6 validators, you need to count your boot nodes as validators nodes too. This is usually how it is done, at least in Noah. Yeah, you only know the difference is like I said, that boot nodes are kinda the first point of contact for any new node that comes up. So let's say you want to join a network, you first need to know where to look, because it's a P2P network, and boot nodes are just those nodes, the first nodes that are contacted, and then later communication flows in many different ways, but this is the first contact. Yeah, apologize. I will be partially turning off my microphone because, yeah, I got COVID last week and I'm still coughing. And my dog is barking too. Hope he will stop quite soon. So depending on what kind of machine you have, this can take a while. So if you're building your own chain, I think it's safety to assume that you are a developer and that you have a workstation, right, or a laptop with at least with at least 6 cores. Otherwise, I mean, it's going to be pretty much pain just to sit there and wait for it to compile. I myself am running a 5800X, so 8 core 16 threads, so this should be fast-ish. Besides that, once this is built, binary can be obviously run on a weaker machine. Doesn't need to have 8 or 6 cores. It can have 4, 3, even 2 cores. It can, yeah. But we did some testing, and it can work with 2 cores, but it's not optimal. Especially if this under high load, then it's not optimal at all. Or when you do the runtime upgrades, then it can take a couple of minutes for everything to process on a 2 core machine. For the RAM size, well, if you're on a dev, probably 16 or 32. For the binary, 4 or even less than 4 is okay. It works. Is it going to be perfect? Not at all, but it works. Okay. Um, I think this will take like just a few more seconds. Besides that, I mean, if you're still using HDDs, well, get out of the cave. You definitely need the SSD for this. A lot of files are being written, and a lot of files are being read and everything. So SSD really helps, and these kind of situations. For the binary itself, I'm not sure. I mean, the SSDs are helpful. Maybe HDD is enough. Okay. Usually takes a while, to building the last packet, which is the biggest one, the AlphaNet runtime, and the mainnet runtime. But that's fine. It can get even slower if we want, if I build it in using the production flags. But this is slow enough, right? So once we are done, we will generate a reference chain specification. So usually you don't want to do it by hand, okay? If you can, if you want, build a chain specification by hand, but this can be annoying and it's super error prone, okay? So what you usually want to do is get existing chain specification and modify it in a way that suits you, right? Hello. Yeah, I think Tanoa CLI, and after that we should have a binary. So why do we need a binary is because with the binary we can generate a reference chain specification. Yeah, that's new. My dog is a new. He's my buddy, helping me, doing those live streams. Uh, because as you can see, the whole room is quite empty right now. I have a huge whiteboard here; it's quite huge, but I didn't have the time to set it up properly. Behind me. Okay, I think we should be almost there. Yeah, so 5.5 minutes. Well, that's okay, I guess. So the binary ones it has been built should be located inside the target folder. We can check that by just doing ls. I think it's target and release, and here we can see now the no by binary there. To make our life easier, I'll move everything around so it's easier to digest. And here I will now create a folder which is going to be called uh, not I will just write prod, okay, because I'm out of ideas, and I will copy the binary from the target folder in here. So we have the binary. Okay, so if we go back to our steps that we need to do. So okay, we have deployed 3 VMs. we build a Toronto binary, and now we need to generate the reference chain specification. In order to do that, we need a binary and we need to execute it. And I will just show you what exactly you need to do or how to get there so that you don't need to memorize everything. But when you call the binary with the dash dash help, you will get a really amazing help screen or however you want to call this. And here we're looking for the build spec subcommand. So subcommands build spec. And let's do that. So it's going to be Tanoa and it's going to be build spec subcommand, and we do help again to get more information. And here you will see all the things that we can use, but the only thing that we need is basically, so I think it's the chain. We're going to use the AlphaNet dev as the reference one, and we need to pipe it somewhere. So if we just do this, it's going to print out. It's useless. So let's let's pipe it out to a file which we're going to call it my chain underscore human.json. And if we do ls in here, we will see that we have this JSON file. And now we're just going to, I will cat it just so you can see how it's a huge one. It's underscore human because it's in human format. So you can see all the text in human format. It can be read and changed. And then you have the runtime, which is just a huge, huge blob of code. So what we're going to do, we're going to follow the next, step, and now we need to generate boot node key. So we can do this in two ways. One way is to use a subkey program from Parity. It's the usage of subkey is to generate all those keys. I think we can do the same by just calling the no binary. Now if you do the no, there's a help is here. We will see it's called where is it? Key. So I think if we do the no and we do key and do help, we can generate a node key here. So let's do it right now. So we will call the no key generate node key, and yeah, and now it's going to spit out two values that we need to store. So the first one is the public part of the key, and the second one is the private part. So I'll just copy this. I will open a new tab here. I will make it. Right now we have generated the node key, and why exactly do we need the node key? It's basically to specify how the footprint of a boot node. Boot nodes. When you connect to a chain with as a validator or as any node, you get this kind of ID, and every time when you connect, you get a different one. To make sure that when you connect as a node to the chain and to have the same ID, we need to tell the node, hey, use this key, and after that, every single time when you connect, you're always going to have the same ID. And the idea is the first one. So what we're going to do is just going to call it boot node keys, node keys. This is our ID, and this is our private key that we need. So this private key, so this public ID, I'll call it public ID. I'm going to private key. This public ID will be shown, so this is visible, which is okay. So this you are okay. You should be okay. You should be okay by sharing that. But this private key is something private. You should keep it somewhere safe where no one can see. I hope no one will steal this while I'm doing the live stream, but it should be fine. Can boot node be changed? Yes and no. Well, if you specify the IP addresses, yeah, you even if it is just DNS names or just IP address, you could kind of change it. But in general, you should not do that. Obviously, when you need to do some kind of upgrade, special node upgrade, there will be some small downtime. But that's why you specify two or three boot nodes, so that in case one is unavailable, you have the other ones. There are a couple of ways how you can force different boot nodes with the dash dash boot node flag when you execute the binary. But this is super, unergonomic, super not ergonomic. It's much easier to bake everything in the chain spec and then execute the chain spec together with the node. Okay, so we have the boot nodes, they are stored here. So let's go back to our steps. So we generated the boot node keys. Now we need to generate the account. So obviously, when you're validator, you need to have the controller and stash. And since we're going to have two validators, we need to have two pairs of private data stored somewhere. That's the secret seed or the mnemonic. So what we're gonna do is going to generate that kind of data, and I'll do a put node uh, control some oh my god controller. So first we're going to generate the keys for the boot node controller. We can do that by executing our binary with the key. Now, if we go help, it's gonna say generate. This will generate a random account. This is something that we want. Now, I would just use, the basic generation, but you can specify how many words should the mnemonic have, and all those kind of things. What kind of key type, blah blah blah, and everything. And in our case, we actually want to do two things. We want to generate the SR version of the account, and we want the ED version. Usually, you don't really need that. So when you're creating your own account, you just need one type of key. Doesn't really matter. The chain should be supporting both. But in our case, because some of our mechanisms later that we will use require actually two different kinds of keys, same keys but two different kinds of encryption. We just need to generate both versions. So what we're gonna do is, so we generated this our version. We're going to copy and paste this. Again, make sure that you copy and paste it somewhere super secure. Otherwise, someone might take it and abuse it or whatever. And that's what we're gonna do is we're going to call a second command, which is not going to be key. It's going to be called inspect, and this will allow us to, I think it's key inspect. Sorry, inspect. And this will allow us to inspect any key. So if I do secret seed, so if I copy the secret seed and paste it here, I'll get this almost the same information. So you can see SS 58 address ends with 7 and Q. If I go up, it's the same one. But this time I want to tell him, okay, so use the secret seed, but I want in a different scheme. So it's going to be ED, I think is to 1559, right? No, it's 25519 and small e. So this will now use the same, secret set to generate the ED format of the key. So just copy and paste this. So this is the SR version boot node, and this is going to be boot node ED controller. Yeah, a lot of text, but we need everything for the later steps. Can you give more details of what are SR and D? I cannot. It's just something cryptographic stuff. I think our colleague Amin would be a perfect candidate to explain the differences. The only thing that I know is that Grandpa, our algorithm for finalizing blocks, it requires a ED key or ED address or whatever I know. But the other components like BAPE, Authority, I am online, they require a SR key or whatever. So yeah, this is what I know. This is the set truth. I think they will change the grandpa from ED to something else, but I don't know when. But yeah, so we are done with the controller. Now we need to do the same for the stash. The stash is going to be in the SR format. It doesn't really matter at this point. I'm not even going to call it SR. So we're going to just generate one more key for the stash. We'll copy it, and paste it here. So, we have the boot node keys. We have, the station controller ready. Now we need to do the same, but for the validator. And since the validator doesn't really care about what kind of node ID it has, we don't need to generate node keys. So here we can just generate, uh, the keys in general. So again, this is going to be validator. Oh, I need to make it bigger. The SR controller. This. Okay. So we take the secret seed, we do Tanoa key inspect. Put the secret seed, okay. The addresses are the same, and now we just say, okay, scheme, what it 25519, right? Yeah. And paste this. So this is validator ed control. Okay. Secret seed, blah blah blah. I think I have word wrap included. I'll just disable it for the moment. Okay. Boot node, validator is already. Now we need to do validator stash count. So there's going to be a validator stash. Besides that, we need to do one more account or generate one more account. And this account is going to be the owner of the technical committee. So I'll just call it TC. Let's do one more round of generating keys and that's it. So that's it. So those are the keys that we need. Usually you don't need to go through this process. But when you're starting your network, you just need to do it. There is no way around it. You need to manually insert all the keys in the database. You who have been running nodes or who are running nodes, you know that you can just generate the session keys by calling one command and it's done. When you're starting your network, you cannot do that. You need to manually specify all those 4 keys, but we will see that later. So let's go back to steps. So we have generated the boot node controller and stash and node key 2. We have generated the wallet controller account and stash, and we have generated the TC account. Now what we need to do is populate the reference chain specification with custom data. So let's do that. So what I'm going to do is I'm just going to open this folder in code. I will show you, first make it bigger, obviously, and show you how the chain specification looks like right now. So this is how it looks. It defaults to one, boot node. If you don't care about this, you can remove it, but we do really care about it, and we're going to populate this in a second. So first, we're just going to change the name of the node. It's going to be called Pernoa, and the chain type is not going to be development, it's going to be live. Live means it's production ready chain. We can leave the ID to alphanet-dev, doesn't really change anything. And for the boot nodes, we need to change the IP address and we need to change the node ID. So the node ID we already have generated. It's here. I will just copy and paste it. For the IP, this is a place where we need to look at our Scalaway machine. This is a boot node. This is the IP address. We will copy and here. So the question is for the TC, we only need the SER. So SR is the default thing. Okay, this is how you work. You can have an ED account, it's fine, but SR is completely normal. The reason why we need ED in the first place is just because of grandpa. That's it. That's all. That's why I make the distinction. Usually SR is the way to go. That's the default. That's the default encryption method, I guess. So we have put the IP address. The port is 30333. That's the default one, and this is the node ID that we are looking for. Every time you connect with a node, the node will get a ID which is going to be, I think, random or something like that. We just want to say, okay, when someone connects to our chain, he first needs to go to this machine and connect to this, node with this ID. While starting boot node, you cannot specify boot node in change spec. This is specifying the boot nodes in the change spec. And there is no validator change spec. There is just one type of change spec, that's it. And the change spec is used by all the nodes. And you need to specify the boot nodes in the boot nodes part of the change spec. You can have as many as you want. You can have 25 boot nodes if you want. But there is no point of it. I mean, even after 3, having 5 is okay, but everything more than 5 doesn't make sense. You don't get anything out of it. Usually nodes, they don't get down, especially boot nodes. So having 3 is kind of, okay. Yeah, the boot nodes refers to itself, exactly, yeah. So my guess is, when the boot node start, the change specification, it will see that it is a boot node, and it doesn't need to do anything special. I mean, though, those tools are quite smart. Okay, we will leave the rest. I'm not gonna change it. Doesn't really matter. The token symbol can be caps. Now, what we want to do is go down. So the whole code that you see right now, that's the runtime. And we don't care about the runtime right now. What we care about is the balances. So we need to set up the balances of our accounts. Here you can see those are, the default one from the AlphaNet-dev chain. We're going to change them. So what we want to make sure is that all of our station control accounts have enough funds. And we're going to do that. So first we're going to start with the boot node, and I'm going to turn off the word wrap again. So our, since SR and, our SR control need to have some funds. And our stash too. Okay, done. After that, the validators, our only one validator guy needs to have it too, so open paste it here. And the stash too. Okay, and I will just remove the rest of the things, so we don't need this. Why is this slow? We're going to have just one more, and this is going to be for our TC. Yeah, we should have 5. So 2 for controller and stash boot node, 2 for controller and stash validator, and 1 for TC. This is our network going to be. This is so if you want to write 1 caps and it has 18 decimals. So if you want to write 1 cap, it's going to be 1 with 18 zeros. This has way more, and I think this is like 1 million. So yeah, all those stash controllers and TC, they're all gonna have 1 million caps. Obviously, for your network, you want to choose the right values. But since we're just doing kind of a test run, this is going to be more than enough. I'm just going to save it. Now, the next part is quite interesting. And here we need to insert the session keys manually in the change spec. Not the session keys, but the information about the session keys, let's say. Let me just make this bigger. What we need to do is here we need to put the SR controller. Here we need to put the AD controller, and here goes the stash. It's quite simple. So let's do that. So we're going to our boot node. So the SR controller, the address goes to authority. I'm online in Babe. Grandpa is special. Here we need to use the ED controller. And then here we have the stash address. That's it for the boot node. So what we're gonna do is going to do one more key for our other validator. So again, we'll take the SR controller, do it here. We'll take the ED, do it here, and then take the stash and do it here. How do you know what to put in the amounts? This is something that, so if you're starting your own chain, you need to define it with whomever you're working with. Okay. So if you usually this is something that your boss will tell you how much caps should someone have at the beginning of a chain. Now there are some clues which can tell you, okay, how many caps should the validators have, and that's basically what's the minimum amount of caps in order to stake. So if the minimum is, I don't know, 100k, then obviously those accounts they need to have at least 100k. The stash ones, the controllers, they can have just one cap or enough caps to do some transactions. That's it. But the stash accounts, so I think it's this one and this one, they should have enough caps to stake. And this is something that we're going to do just right now. So once we are done with the session keys, so I'll repeat once more. Here goes stash, ED controller, SR. Same here, stash, ED controller, SR. Like I said, Grandpa is special. He's old. He's a boomer. Okay, everything else, Grandpa ignore, blah, 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 blah. And we go into staking. Here, what we need to do is we need to use stash, controller, and amount of caps that we want to be staking. And in this case, this is, let me see, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 100 caps. What we're gonna do is, again, since our boot node is a validator node, here boot node. So what we're gonna do is take the stash account, take the SR controller, and put it here. We're going to just copy and paste the same for our other guy, the validator guy. So stash and SR controller. Save. Now here you can also put nominator if you want to have nominators, and you can put some other information here that you want to now have, like history depth, how many how much data should be stored on the chain for the last 84 blocks, blah blah blah. What's the minimum nomination bound? What's the minimum validation bound? Blah blah blah. So if this is, I don't know, set to 1 million, then obviously when we stake, we need to put at least 1 million, and our accounts need to have at least 1 million. The stage accounts. Okay. The last thing that we need to change in the chain specification is the technical membership members. In this case, we want to have our own account there, the TC guy. So we just copy the SR count and put it here and done. That's it. Our chain specification should be okay. If you want to fiddle with it, sure. Just make sure you don't touch the big bad blob of runtime, because yeah, it's the runtime. So if you go up, just double check. So our network is going to be called Pernoa. This is our boot node. Let's just double check the addresses are correct. So it's 163.172.130, and yeah, 163.172.130 and 7. So this is correct. And boot node ID is this one. It ends with PQ, and this has PQ. So everything seems okay. We should have five accounts in the balance. Let's just count them: 1, 2, 3, 4, 5. They should be controller stash, and TC. And here needs to be stash, ED, SR controller, blah blah. Okay. To me, it seems everything is okay. Stash control. Let me just double check this. Yeah, it's okay. We save this. So this is in human format, and let's see what's the next step. So we generated. Now we need to. We generated all those accounts. We populated the chain specification with our custom data, and now we need to generate the raw chain specification. This is quite simple. So what we're gonna do is we're gonna do the same process as last time. So we're gonna build a spec, but instead of feeding it with the alpha net dev chain, we're gonna feed it with our own chain. So this is how it looks like. So we're gonna do Canoa. We're going to do build spec. We're going to say, instead of AlphaNet dev, whatever, we're going to write my chain. And we're going to do, I think it's dash raw, to have it in raw, and then we need to pipe the results to my chain. underscore raw.json. I think it's oh, build spec, not build sec. And it's done. Now, if we go to Visual Studio Code and see, we now have the my chain raw, and I will show you now the difference between those two guys. So let me just scroll up. So the first part is the same. So there is no difference between how it looks. The boot nodes is in human form and everything. But once you go to the Genesis, it starts to look differently. So we have Genesis runtime system, blah 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 blah. But here we have raw and top. So this is now going to be just basically a huge hash map with a lot of data. And if we go scroll down, here we change some of the balances and staking stuff. But if we go down here, we don't have that anymore. So everything is in a raw format. Now the question is, okay, why would we need the raw format in the first place, right? There's nothing wrong with the mind chain underscore human chain specification, and the raw format seems like cool, but you cannot read anything out of it, right? It's just unreadable. Well, the reason behind that is how the node uses those chain spec and how it generates the Genesis block. So in order for two nodes to communicate with each other, they need to start with the same block, with the same Genesis block. They need to start with the same hash. So when they execute the chain spec, they generate the Genesis block. The Genesis block will have a hash. Now, I think especially if you're in the dev, you know that it depends on a lot of things how that Genesis block will look like. You can have the same code and everything. You can run it on one machine, on a Windows one, in a Linux one, in a Mac OS, and you're going to get 3 different Genesis hashes. They will have the same data. They will have everything the same, but the Genesis hash is going to be different. To make sure that whoever runs this gen spec will always get the same Genesis hash, we need to we need to supply the raw format, not the human one, because again, when you have the human one, it needs to do some uh, calculations, and it will generate the Genesis block, and the Genesis block can have different Genesis hash if raw format is not used. Now, I will just speak about the Genesis block for 2 more seconds. Genesis block is nothing more than the first block, or the block under number 0. That's it. It can contain some default data. It doesn't need to contain some default data, but it usually contains the balances, and some staking information, and everything what you can see here goes to the Genesis block. In most cases, the Genesis block is quite lean. It doesn't have too much data, only the necessary to start a network. But if you use one of the procedures like the fork of subset procedures, you can get a chain spec which is quite fat, contains a lot of data. And this is something that we'll try. Maybe not today, probably tomorrow. But yeah, let's continue. So we have the raw format, and now we need to go back. Okay, we have the raw format. We are done with setting up the chain spec. We are done with this part. Now we need to configure our VMs, and this can take a while. So it says here we need to copy the binary, copy the raw chain spec, create a service file, and then insert the grandpa babe line of authority keys. This will probably take me, I don't know, 20 minutes. I'll do my best to amuse you, but it's not really something super fun. So what I'm going to do here is just going to create a new tab. Obviously, I need to make it a bit more readable for you. And what we're going to do is we are going to be, as I said, we're going to enter all our VMs. So let's first start with the boot node guy. So just copy and paste address. Okay. Since Scalaway is recycling, IP addresses, one of the previous machines had the same IP address or something or whatever. I just had to clean from my own registry the information about that. Okay, so we have the boot node. I'll just clear it. I will do the same. I will immediately connect to the validator node. Okay, let me make this a bit bigger. I'm not sure if they are the same size, but doesn't really matter at this point. I will see it. So validator, copy the command. Probably going to get the same message. Yeah, blah blah blah. I'll just do this. Oh my god, no. Okay. Yes, please let me go inside. Oh, please let me right click. Okay, so make it a bit bigger. So we inside. Usually what you want to have is have a separate storage block connected to your VM. So in case you want to change the VMs, you just need to detach the block storage and attach the different machine. We're not going to do that right now. So this is not a DevOps course. This is how to configure your uh, private or public network. That's it. So what we're gonna do is we're just gonna go to opt here. Here we want to copy and paste all the data, all the files that we need. In this case is the binary, it's their own change specification file, and the service file we will generate ourselves. So let's do that. So what we're gonna do is we're gonna SCP the binary. It's gonna go to root 163.172.1.130.7, and now we need to specify the path. So it's colon slash opt slash, and it's done. Now we're going to do the same with our change specification, my change specification raw.json, paste it, bam, done. So we're going to do the same. So if I do here ls, now I have those kind of things. Sorry, the binary and the change spec. I will do the same here too in the beta. So I'm going to do go opt and then just paste the data here. So it's not this address anymore. IP address, it's 51.15.131.97. Okay, let's do the same for the terminal binary. Okay, we are good. So on both machines, we should have all the data that we need. The first things first, let's generate the service file. So I'm not expecting you guys to know out of your head how to do this. That's why if you go to the GitHub page of the node, go to the wiki section. Here you can see a lot of cool information, but what you need is the systemd service files. I think it should be called just file, but whatever. So it tells you to put the service file in etc systemd system the node.service. So we're gonna do that. So I'm gonna copy. So right now we're gonna first do the put node. So I'm gonna copy the code that we need, or sorry, the text that we need, and I'm gonna do nano etc. Obviously, if you're using Vim or Max, it's fine. But I'm a Nano user, and we're gonna have. So since the network is called Pernoa, I'll just call it Pernoa service. So paste the information here, and let's just change it. First, we're gonna do is we're gonna leave the name to be Pernoa, but we're just gonna call it Pernoa, and if we're going to do the chain is not anymore mainnet, it's called it's we need to put a path to it, so it's in the opt opt, and I think it's called my chain underscore raw.json. The destination for our blog data is going to be inside opt node data. It's should be in state pruning archive. It means it's gonna store all the states of all the blocks. It's gonna be a validator. Now we need to change the node key. Here we need to put our private node key, which we have stored somewhere, which is here. So private key, right click, copy. Here we're gonna paste it, and that's it. This is how our configuration looks like. And this also tells us that we should put we don't need, but we should put the terminal binary inside user bin. And this is what we're gonna do. So we're going to save the service file. We're going to do Sure, we're just going to do a copy to know, and it needs to be, I think it's user bin, right? Let me just do once more cat systemd system Tanoa. Yeah, so user bin Tanoa. Let's just see if we have Tanoa in user bin. I think we have. Where is it? Tanoa, yeah, we have it. So we are fine. So we're gonna do the same process, and I just yeah. So I just realized I made a validator and not that the boot node, but doesn't really matter. I'll just change our service file script. Newbie mistake, not a big deal. etc systemd and we Pernod. Okay, so what I'm gonna do is go to the boot node, create a service file here, system Pernod, Pernod.service, and I'm gonna copy paste everything from here. Oh no. Okay. Right click, copy, paste, and this should be fine. And here, since it's a validator, it will be validator node. Going to be the Noah, let's call it validator. The chain is okay, everything is okay. The only difference is we don't need a node key on a validator. So this is the only difference between a boot node and validator. When you configure them, boot nodes have node keys. Okay. Yes, I will start them later. Yeah, I know I need to do U plus X for to know to make it executable. I'm just slow. That's all. But I think it's already executable. If I do like that and I do version, I should it works. It also help. So it's all executable, which is quite nice. So we have this, the service file located in the right place. Why do we need the service file? It's just easier, to run your network when you have those kind of things. It automates everything and it allows you to, for if something happens, let's say restart, the node will automatically restart to as long as you enable the script. But right now I'm not gonna do that because this is something that our dearest friend Sufyan will maybe show you later. The private key, the node private key is to make sure that you get the right node ID. Like I said, node IDs are random. So when you start your validator public, whatever, you get a random node ID. But in our case, we want to make sure that our boot node has always the same node ID. So even if we restart it, it will have the same node ID as long as we supply the same private node key. And you saw in the change specification that we specified the IP address and we specified the a node ID. So these two things cannot change. If they change, obviously no one can connect to our network. So yeah. Okay, so validator should be set up. Boot node should be set up. So let's see what we need to do. I think I need to move the node to user bin on the boot node. Okay, it. I'll just do no data folder here. The same here too. And let's go next. Let's see what is the next step. So we have done that, and now we need to start the nodes and insert the grandpa babe Mulan and auth keys. This is going to be a bit annoying process, but it's fine. So what we need to do is we need to create a script which is going to do that. So just copy and paste this. Yeah, it's really hard to see. So I'll open it in Kate. Yeah, this is one of my test runs. So this is a script that we're gonna use uh, that we need to use in order to insert all the keys that we need. So usually when you do your session keys or rotate keys, you just execute one command and bam, they're inserted. But in this case, we cannot generate a session key, so we need to manually insert those keys. And this is just a small, script that does it for us. What we need to provide is the seed, the I think it's the mnemonic, but I think the seed can work too. The grandpa key and the non-grandpa key. In this case, this is the ED, and this is the public one, the SR. And let's do that. Let's populate it for the first uh, node, which is the validator node. And the only difference is that instead of for the SR and the ED, we need to use the public key. So boot node SR controller, the public key, it goes into the non-grandpa here part. And if I go back to boot node ED, I take the public key and it goes into the grandpa key. I mean, this can be called, ED key, and this can be called, SR key. I think it should be then easier. So ED key. And for the seed, we're just going to copy the secret seed from here. This is now the script that we need to run, and let's just do it. So let's first run the network. Let's hope it will run. So if I do systemctl start Pernoa and see the status of it. So I didn't. Yes, okay, I made a mistake. Let's see what's the mistake. So just journal Pernoa f invalid node key. Okay, so what I have done is probably I didn't copy the key properly, which is okay, it can happen. So system and then it's Pernoa. And if you see we have some weird characters here. Let me try to fix that and paste this key now this time properly. So private key, Control C, here node key, paste. Should be now okay. Save it. Now it will tell me there are some changes in the systemd. Okay, let me hide this. Systemd file. Okay. Reload. Start. I think I can use restart, but okay, I know that this works. Stop. And I think you cannot really see because I'm kind of blocking. So let me see if I can do something like this. Okay. Or I can just remove myself from the screen. But yeah. Okay. This should be now okay. Okay, let's see if it runs. It's active and running, let's check the journal and see what's going on. So it cannot do anything. It cannot produce blocks. It waits for one more validator to connect. So it's perfect. So what we're gonna do is we're gonna create our script, which is here. Copy. What I'm gonna show you. So if I go to node data and change the AlphaNet here, you will see if I go to key store that it's empty. So there are no keys stored. So if I'll go back and go back and I do touch, I can actually just do nano and run.sh, paste the script here, save it, make it executable, say mod u+x run, and if I run it, let's hope it will work. Invalid hex character, okay. Did I mess something up here? let's see. Oh yeah, obviously I'm missing the dollar sign. Okay, not too shabby. Let's do nano run. Gosh, okay. Let's just add manually here. Should have done that in the first place, but okay. Let's try again, and it's fine. So it says you should have 4 of them. 1, 2, 3, 4, and now if I go to key store, no data, change AlphaNet key store. Now I have the 4 keys in here. To make sure that they are applied actually, what we need to do is we just need to do a systemctl restart of Prenoa. This will make sure that those keys are actually applied. And now if I check the journal, it should start running. So I will leave it like that for now so that we can see if something is going on. Now we're going to jump to the validator and set up the validator. So again, it's the same here. So we need to take the secret seed, place it here. We need to take the ED public key, and then the SR, which is this one, the public key. That's it. Copy. We are here, so I'm going to do nano run.sh, paste, chmod, x run, and systemctl start Pernoa. And let's see if it is running. It is fine. All our script. We get 4, which is great. Let's just double check it. So we're gonna do ls no data blah 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 key store. We have 4 of them. We need to stop and start. Stop and start. And let's see if it will work. So journal view Pernoa F. Okay. So as you can see, actually something is now going on. So what I'm gonna do, I just gonna go back to our previous screen. As you can see, at the beginning we only had just one node working, and that's all. That was the boot node, and it had 0 peers, which means that this was the only node, and our boot node isn't connected to another node. It isn't talking with another node. But here, as you can see here, from here, we started to have a second node in our chain. So it says discovered external address per node, and now it's 1 peer. So 1 peer means there are actually 2. Okay, I think there is a configuration where the maximum amount of nodes that you're connect to is maximum 50, I think, something like that. This doesn't mean anything. You can have 10 peers, you can have 15 or 50, it doesn't really matter. Okay, it's the most important part is that you have some peers. But in our case, since we have just 2 nodes and they're close to each other, they're in Paris, they are connected and they talk with each other. Now, the second most important thing to see if it works properly is that this important number needs to be in increasing manner. So we have 1, 2, then we shut down our old node and start it again, and now it's increasing. So this is the number of blocks that we have right now, 17. And the second thing is that the gram is the fact that finalization should be working, and this can be visible by having the finalized block being increased after 6 seconds. So yeah, it works. So the block production works, the block finalization works, everything is in a place. Those 2 nodes are communicating with each other. The second node was able to connect to the first one because we specified in the change spec where is the location of the boot node. If this wasn't specified, then our second validator node would have not connect to anyone. It would know where to go. Okay, so we are done with the boot node. We are done with the validator node. The last step is to set up the public node, and let's do that. So first what we need to do is actually connect to the public node, and let me do that. New tab, make it bigger, connect. Again, I need to clean up my local registry. Connect, yes. It says it here. Okay, so it says we need to do SCP. So let's do that. SCP. The address is 51.15.224. So yeah, I think Leo, you asked you can have as many as you want. Now imagine that you have 50 boot nodes and you need to set up all of them. I mean, you can do some magic, you can do some magic, but it can take a while. That's why you want, at the beginning, the minimum amount of nodes, and then add it later through the UI or by just the normal way, But okay, so we have transferred Ternoa, the binary. Now I need to do the same for my chain raw. Okay, this is done. Let's go to opt. Everything is placed, so let's just do cp Ternoa. We'll move it to user bin. Perfect. And now we're going to generate a service file, which again, if we go to the wiki page here, we see how the service file should look like for a public node and the location where it should be. So we're gonna do it. So we're gonna do nano etc systemd system and then Ternoa.service. Paste the code here, change it to public. Okay, the chain is in the opt folder, so it's opt my chain underscore raw.json. The place where to store the node data is going to be in the opt folder. Pruning, okay, external, so everything's in place here. Before we continue, I think we need to do one more thing, and that is to set up the NGINX server. This is quite easy to do. Basically, we want to have a secure connection so that we can connect it via Polka JS UI. I'm going to create a certificate. Not gonna use the existing one, so I'm just gonna follow the commands that are written here. So first we need to install nginx. Oh my god. Yes. After that, we need to execute this command. Come on, don't block me. Oh, this is annoying. Copy. Paste. Doesn't really matter. And the second command will take a while, probably like a minute, I think. So let's see if there are any comments. Yeah. I mean, in a real production environment with a real product, you want to have a certificate. Okay, here I'm just generating my own certificate from my own needs. Okay, after that we need to create a script inside etc nginx sites enabled. I'm going to call it Ternoa. Doesn't really matter. I should call it Ternoa, and I'll just copy and paste data from here. The only thing I need to change is the server address. In this case, it's the one of the VM. It's going to be 51.15.224.74. And I think I need to start Nginx server. And now if I connect to this VM via internet, it should be working. Let's see. So it's 51.15.24.74. Yeah, welcome to NG. So the normal way works, but this is not the secured way because it says, not secure. So what we need to do in order to tell our browser, hey, even if this is not secure, it's kind of secure. So what we're gonna do is we're gonna copy and paste this and write HTTPS. And this will say, hey, the connection is not right. We can just ignore it, okay? And proceed to and save. And this is fine. So we enable it and say, okay, even if it's not secure, just treat it as secure or whatever. And then what we're gonna do is start our, uh, start our binary or to our default directory, which is opt. So we do systemctl start terminal. See if it works. Let's do journal u f c. So it has connected. So the public node has connected to it. So it has discovered external address. It has connected to those nodes, and now you can see it's ideal too. If I go back here and scroll down, really down, you'll see two peers. So we managed to connect, and everything seems okay. The only thing left is to go to Polka.js UI and to actually connect to the nodes. And I think it's going to be WS, and it's going to be 51.15.224.74. Let's see if it will work. And it works. And now we are there. If you're having issues here and you cannot connect to your node, it means you didn't do this step previously where you said, okay, even if it is, prior to whatever, no, just do it, just do it. And that's it. We have our own network fully complete, fully running. It has two nodes. They are generating blocks. They are finalizing blocks. The block time is 6 seconds. We can change that. Obviously, since we clone the repo, we could change to 12 seconds or 1 second. It doesn't really matter. But everything is in place. Are there any questions? Yeah, it was even less than 2 hours. It was, 1 hour and 15 minutes. And since, I have some time left, I could do the fork off procedure right now. But let's see. I mean, the whole process isn't really that complicated, to be honest. The only issue is, it's kind of tedious. That's all. This was example with two nodes or three, a public one, a boot node, and a validator. On the real chain, you're going to have more boot nodes, you're going to have more validators, and it's going to just take longer. Unless you have some, magic scripts, some magic, magic bash skills, then probably it might even take less. But this is just it, Usually when you start a validator, like I said, you just do, the session key command and that's it. But in case like this, you need to manually insert all those keys, and having a small script really helps. Otherwise, writing it down manually, it can take a while. Okay, so the script, I'll put it in, in the, yeah. So the question is, where is the script located? Let me see if I have put it on Wiki. I think I haven't. So I will just create a new page and I will write it manual key insertion. And I'll just copy and paste the data from the script from here. So seed E key, SR key. Yeah, the data doesn't really matter, to be honest, since it's a test. I should probably put it inside the code brackets. I'll write bash should look more natural. Yeah, it's better now. There are a couple of scripts online like that. Uh, there are a couple. Okay, so just to say one thing. So this is one way how we can do it. Okay, this is one way how we can insert those keys. There is actually one. There is one more way. So this is the I call it the hot way. It's because you need to have a running node to actually insert them. But there is a cold way where you need to have a running node, and you can do that. So if you execute the binary, you will see it's called, I think if we just go key, the subcommand key, we have this insert a key to a key store of a node. So you can do it in a cold way. So instead of having a node being running and then hot inserting them, you can just cold insert them and it should work too. But I haven't tried myself. It should work definitely. I don't see why. But if you want, you can play with it. Uh, no, it's up to you guys. Yeah, I can show you the change spec. I can even save it so it's here. Yeah, I will share it too. Where is GitHub? Example change spec. We'll see if I actually can do this because it's a huge file. I will just write. I think it's. Let's see if it will break. No, it's fine. It's too long. Okay. I will omit the runtime code part. Yeah, I'll just omit it. Come on. Come on. Yeah. I mean, they're all. Yeah, sure, I can do that. So in the change spec, so the only place where we use a key instead of an address is in the script. I should probably. Oh wait, it didn't even copy everything. Oh Jesus Christ. Okay, this is what I'm gonna do. So what I'm gonna do is I'm gonna go to paste bin. I'll create a new paste. And I'll see if it will work. Okay, it kind of works. So paste name example chain spec. Okay, so I'm gonna do example chain spec. A link. You have exceeded. Oh my god. Ah. I hate this. Oh, I'll do it manually. Code. So I'll delete the whole runtime and then I will paste it because it seems like it's way too many info. I mean, it's a huge file. I'm not lying. I'm not gonna lie, but it's annoying. Come on. Just a bit more. Okay. Okay, go down. It's here. Okay. I'll just write 3 dots. Okay, now I can actually copy and just paste it here. JSON. Okay. Oh, it's now okay. So yeah, so the only place where you need the ed is the grandpa. That's it. Everything else is SR, and you use the SS, SS58 format. The only place where you don't use the SS58 format but use the other format, with the hex format, is in the script. So in the, where is it? Here, I'll just write it down. So you use the name of it. He used the public key hex. This is ed controller public hex, and this is sr controller public hex. This is the, I mean, it could be the mnemonic if you want, but I usually put secret seed of sr controller. I mean, it's the same, doesn't really matter. The ed and sr have the same, controllers. Secret seed. Save. Where is it? Save. And on the change spec, not change spec, where is it? Example change spec. Yeah, like I said, in the balances you put obviously controller stash and the TC or whatever accounts you want to have. And here it's stash ed controller sr controller stash ed controller sr. And down here you have stash and controller, and then here you have the TC member. So I think this is the only step that we haven't done. We haven't checked if we have access to the the TC guy, and let's do that. So what I'm gonna do is I'm gonna import the TC accounts. I go accounts, add account, raw seed, put my raw seed, text name, TC admin, text, save, blah blah blah, and I should have it. Yeah, it's here, TC, and if I go to technical commit, I can see my account, and that's it. So right now, what we have is, yeah, it's too valid, but it should be just one. Is going to fix itself next iteration. So what I should have done in the first place is, when you go down, since I have two stakers or two validators, I should have put the validator counted to. This is something that I forgot to do. That's it. So if you're gonna start with 10 validators, put 10 here, right? If you're gonna start with 1, put 1. Right now we have started with 2. I have put 1. Then it looks a bit funny, here. Just put 2. That's it. Okay. Any other questions? If not, let's proceed with the fork off procedure. It should be a really quick and easy one. So in order to actually execute the fork off procedure, you need two things: the WASM file and the binary. You can get both of them if you just build the code. So if I go here, cd is live test, no node. If I go to target release, here I will get the binary. So it's the green guy. But if I go to w build, if I go to mainnet or alphanet, here I should have the WASM file too. So you need both the WASM file and the binary to actually execute the fork of subject procedure. So what we're gonna do first is actually get the procedure, and it's located somewhere in our umbrella repo. So it's the Noah fork of, yeah, it's here. So what I'm gonna do is just gonna clone it. Git clone. Go to Noah fork of substrate, and here I need to create a folder called data. So obviously first I need to install the dependencies. It's a Node.js application. So then I'm going to do create a data folder, and inside the data I need to have the binary and I need to have the WASM file. So I'm going to just do cp copy it from the node target release the node, and it needs to be called binary. It's not the node, it needs to be called binary. Now we need to do the same, but instead of the binary, I will do for mainnet. We need to do it for the WASM, and here we will do mainnet compact WASM, and we will call it. I think it needs to be runtime.wasm. So if it should be okay. We have the binary, we have the runtime wasm. So if I do cat readme, go up, I think I should be okay. So yeah, create the data folder, copy the subset based binary, name it binary. We have done that. Copy the wasm blob, name it runtime.wasm. Okay. We have done that. It tells you that you should be looking for the compact.wasm file, because there are three built WASM files: the WASM, the compact WASM, and one more. Okay, now what we need to do is we need to set up some environment variables: original chain, fork chain, click mode. So first we're going to do is we're going to set up what's the original chain. So we're going to do export, copy, paste, and this will be equal to we can do just mainnet dev, and we'll do the same for fork chain. I will explain later what exactly needs to go here and why we used no. And we will set a quick mode to true. So export, copy, paste, true. Okay, our environment variables are set. By default, it searches for a local copy of the node, okay, by default. And this is something that we're going to provide him, okay. So I will go into data, and I'll create a folder called node data. And then here I will execute our binary node. I will put the data into node data. I'll use the presentation. I will say, okay, the chain is mainnet, and the method of syncing is going to be rep. So right now I will create my own node. I'll actually not create, I will run it. Oh my God, warp. And this will allows us to have our own node running on our local machine, which means that we have access to the node itself without going through any secure stuff, because it's running locally. So okay, this is normal. Okay, so let's wait for the latest state to be retrieved. It's done. So 24 megabytes. This is the size of the chain. Usually, yeah. So the question is, do we need a local node to sync up with the chain? Yes and no. So if you have HTTP access to the target chain, then you don't need a local node. But I don't think that we have by default HTTP access, only HTTPS, which means that in order to get HTTP access, you need to have a local node running. You need to run a local node. That's just how it is. So we have a local node running. It's now trying to seek all the blocks. It works perfectly. So yeah, let's go back. Now what we need to do is actually just run the procedure, and that's it. And we do it npm start. And let's hope it will work. And it works. Now what can happen is that if there is too much data on the server, this procedure will fail. Okay. And in order to fix this is you go to data, delete all the things that have been generated. So our storage, runtime, hex, fork, Genesis. Just delete it. And go back to your node, stop it. And you need to use one more flag to make sure that you can download a lot of data in one go. So I think it's called something like RPC max something something. And I think it's called, yeah, it's either request size or response size or payload. Payload, it says, is deprecated. It has no effect anymore. Use RPC max request size or response. So we're going to do is use the response size, copy, and set this to, I don't know, let's say 10,000. So this is only in case if the target chain has too much data and it cannot get it in one go. You need to use this flag. Now, if I run it again, it's going to be fine. So npm start, say it works just fine. So now we have a change spec. We can check it. So what's going to do it? I'm going to do code dot. And we can see that in the fork JSON, we have a change spec in the raw format. So once a change spec is in the raw format, you cannot convert it to a human one. Okay. Once in a raw format, always in a raw format. You cannot go back. Sorry. So this is the whole data. So this is everything from the mainnet right now. We have skipped some of the pellets, but this is, NFTs, this is, marketplaces, this is assets and everything. And what we're going to do, we're going to run it. So I'll stop the previous one because we don't need it. And instead of putting the data into node data, I would say, okay, save the node data into temporary folder, and the chain is not anymore mainnet, it's fork.json, the one that we got. Sync warp, we don't need that, we don't need anymore any of it. And we're going to say, okay, this is a Alice node, it's a validator, and state pruning, I think it should be archive. If you run this, yeah, I forgot. So once it generates a fork, I forgot to change that. We need to remove the default. This is the default boot node. Just need to remove it. That's all. We remove the boot node because there is no point of connecting to anyone. We run it, and bam, we have our own fork of mainnet with everything in it. So let's see. So it's producing blocks. Let's see if it's going to finalize blocks. Yeah, it's finalizing. So what I can do is I can connect to it. So I do local node, and then we are here. So it says to know mainnet development fork. This name can be changed. Mainnet, and now if I go into change state, and if I go into NFT, I should have all of them. The script has skipped some pellets. The reason is because you don't really need them. Like you're forking up a chain, you don't want to fork their staking data, or their validator data. Otherwise, it will be impossible to run your chain, right? So if you have that data, mostly how check the script. It's a super easy one, so I'll just show you. I'll just show you. Code. I go index, and in here you have, where is it? Yeah, here. Skipped module prefixes. Here you can put all the prefixes that you want to skip. I know it says system says, session babe, grandpa finality trunker, alpha ship. So all those pellets are completely useless because, you cannot run a new chain if you get the babe and grandpa data. It's just not gonna work, right? Because it will expect the same validator set, which you don't have. So yeah, we skip this, but we don't skip the system data accounts, and this is the place where all the balances are stored. So the balances are not stored in the balances palette; they are stored inside system data account. This is quite important to know. If you want to skip all of them, or you just want to have one or two pallets and that's it, you can do it in this script, right? The check is done in here basically, so you can do whatever you want. It's up to you. The script is quite small. It has only like 186 lines of code. It's easy to understand and quite handy. Okay, that's it for it. So it's running perfectly. We have all the NFTs, we have all the marketplaces. Let's just double check it. Marketplaces. Yeah, it's here. So all the data. So this is quite useful, especially if you want to test, some, let's say, runtime upgrades. You get, the data from the mainnet, you launch it as, a separate chain, and then you do a runtime upgrade on here. The most important thing is that the runtime name, the names of the runtime, they need to match. So if we're talking about mainnet, okay, you want to use the mainnet-dev chain spec. If we talk about AlphaNet, you want to use the AlphaNet-dev chain spec, right? That's the only catch. So once AlphaNet starts working again, when you want to fork the data for original chain and fork chain, use AlphaNet-dev. If you're getting data from mainnet, make sure it's mainnet-dev. I'll just show it. It's it's okay. Just do cd cat readme. It's this one. So original chain. If we talk about mainnet-dev. If this AlphaNet-dev, the same for fork chain. That's it. Alice. Wow. Okay, I think we are still live. I hope so. Are there any questions? I just lost internet connection for in a couple of seconds. That's all. Yeah. I mean, the original trend you can put mainnet instead of mainnet-dev, but doesn't really matter. Really, it's easier if you just put mainnet-dev in both places. Yeah. So the question was that I have specified the same a chain specification for original chain and fork chain. And the question is it the right way? It's one way. You can use for original chain, you can use the mainnet, and then for fork chain mainnet -dev, but doesn't really matter. The most important part is that you have mainnet -dev on fork chain. Original, you can have it mainnet and mainnet -dev, doesn't matter. It's just easier if everything is just dev, Obviously, you are not going to start a new production ready chain by using the fork procedure. This this is something that you should not do. This is just for testing. Uh, Once you get the data, once you fork the data, you can do whatever you want with the data. But obviously, you won't start a completely new chain with this data because it misses a lot of things. There is a way how you can start a new production chain with this data, but this means that you need to know you need to change the node code. You need to do some changes, and I'm not going to go into this right now because I think it's unnecessary. But yeah, if you supply a different origin chain and a different fork chain, you can do you know wonders, but better not. Anyway, those kind of chain specification, it's quite easy to make a mistake, especially if you have a lot of nodes. So it's always better to double, triple, or quadruple check it. It's always better to have it in a human form first, so you can check it and then convert it to a raw form. Because, like I said, once you have it in the raw format, that's it. You cannot go back, and the fork of subject procedure generates raw chain specification, which are completely unreadable, unless again you make a tool which makes it readable. It could be a nice exercise. Okay, any more questions? I mean, uh, if that's it, if that's it, I'll close this session. I hope it was concise and straightforward. I think it was compared, to my previous life coding. This should be, quite easy to digest, and you can just follow it on your and as long as you know how to use a terminal, how to use Git, you should be fine. If you don't know how to use a terminal, then you're probably in the wrong neighborhood, fool. Okay. Okay, I'm just joking. That's all. Thank you, guys. And I just noticed there's a Tanoa watermark on the upper right part of the screen. That's annoying. Okay. Yeah, this has been recorded. It should be available on YouTube. Uh, on Twitch, I'm not sure because I think we don't have enough followers there or subscribers or whatever. But it should be available on YouTube. If not, the team that is responsible for doing this will make it available. Anyway, thank you guys, and I hope Sufyan will make a. So this will be the next part where Sufyan or someone else, they go more deeper into the DevOps part. We really skimmed through it, like really, really skimmed through it. The certificate part, Nginx and everything, we really went fast through it. Setting up VMs is way more work. Securing them, we even didn't talk about securing them at all. So there's way more DevOps work to do, including but not limited to, tooling, checking if everything is running, and yeah, our DevOps guys, Sufyan and Charles, they're really good at it, and maybe they will make a video about it. I sadly don't have the expertise to do it. I don't know how to set up the DNS and all those kind of things. I'm just a tech guy, that's all. But yeah, anyway, Thank you guys and see you later, alligators. Bye bye.